Hello, my name is Sunyoung Park, and I'm going to introduce a paper titled An Analysis of Azure SQL Database Always Encrypted. So this paper was published by Microsoft, and in the paper, they explain the version 2 of Always Encrypted technology that they are using in SQL Server database. I will start with the introduction, explaining what is always encrypted and some background, and I will explain the difference between the version 1 and version 2 of always encrypted. This paper is about version 2, and I will show you some analysis, performance analysis, and finish with conclusion. So, the integration of cloud services has become norm to business infrastructure, and this shift towards cloud adoption has promoted a lot of companies to migrate their data to cloud providers. However, trusting data uh, trusting data to cloud services implies um, granting administrator privileges to third-party providers, which raises concerns about data security and confidentiality. So, in response to these challenges, Microsoft has introduced a solution known as Always Encrypted. So, it's a distinctive feature embedded within Microsoft SQL Server, and it empowers data owners to leverage encryption at a granular column level. So it ensures the confidentiality of data at all stages, even when it's not used in the database, which means it is at rest on storage disks, and even when it's utilized by SQL Server, and also during transit for processes such as backups and result communication. So basically, it means that the data is not going to be revealed or is not going to be decrypted at all in the SQL Server side, and it is only decrypted on the client side only. So, however, that means that whenever there is a process, SQL or query processes that has to be performed in the SQL Server side, that has to happen on over ciphertext, which we can simply think is going to be expensive. So to overcome this challenge, um, Microsoft introduced a specialized encryption scheme enabling computation over ciphertext and also increasing the functionality and performance at the same time. So initial version of Always Encrypted relied on the deterministic encryption, which produces the same ciphertext for a given plaintext, facilitating equality operations over ciphertext. While functional, this approach presented a notable drawback. So, as SQL Server lacks the encryption key, enabling encryption for the first time, and key rotation necessitated round trip to client system which possesses the key. So, uh, we can think that could be very expensive because they need to go back and forth for the to find the encryption key to process these queries. And also because they were using deterministic encryption scheme, they could only perform like equality operations such as point lookups, equijoins, and equality-based grouping. To overcome this drawbacks of always encrypted version 1, they came up with version 2 um, to increase the functionality and confidentiality also performance. So the key points in the version 2, one of the key points is trusted execution environment, which is called enclave. So an enclave is a part of virtual address space of a process, and it includes code and data that is shielded from the rest of the process and operating system. So whatever happens in the enclave cannot be revealed to the SQL Server or operating system, and which include that um, enhances the confidentiality of data by preventing its decryption within the SQL Server. So TEE is an evolving security technology enabling the execution of a trusted code enclave within a large untrusted host process, as I said. And as I said, again, this enclave operates independently, shielding its computation and state from the host process. So the purpose of enclave is to increase the functionality of always encrypted, but at the same time to ensuring the confidentiality of data. And about the encryption scheme in always encrypted technology. So AE, always encrypted, employs a two-level key hierarchy. Data is encrypted using a column encryption key, and this column encryption key is further encrypted using a second-level key known as column master key, which is stored in the client side. The server side cannot see this key at all. And two encryption modes, deterministic and randomized, are employed. So deterministic, as I said, version 1 only used deterministic encryption, and it facilitated equality operations using ciphertext, but it lacked frequency distribution. But by using randomized encryption, they could support additional operations like range queries when enclave enabled. I think it'll be more straightforward or easy to understand if I explain how it works step by step. So AE operates through a multi-step process, ensuring secure communication from the client to the server and back. So in always encrypted, SQL Server is designated as untrusted, while the SQL Server, SQL Client, Enclave, and Attestation Service are trusted component. So this dark part means it's untrusted, and the white part here, Attestation Service and Enclave, they are trusted components. And data is stored encrypted at the column level within SQL Server, and encryption keys are distributed across only trusted components. So the keys are not going to be here saved. It's not going to be saved here. SQL Server will never know the encryption keys, and the keys, when needed, they are going to be shared only among these three components. Key provider too: application, attestation service, and enclave. So first, the client initiates a process by issuing a parameterized query with plaintext parameters and expects result, of course, in plaintext. To deduce encryption type information and keys, the client driver utilizes a new API, which is implemented within SQL Server. So when they initiate this call to use this new API, it provides the encryption type information for each parameter, and if enclave computations are required, the output also contains the set of encryption type information needed within the enclave. So if enclave computations are necessary, SQL Server calls a trusted attestation service to make sure that there is no problem like breaching or no like component faults, and it provides attestation information to the client. And this information establishes a shared secret between the driver and enclave so that they can communicate using that shared secret. And SQL Server acts as an untrusted intermediary in mitigating communication between the driver and the enclave using shared secret. So as I said, SQL Server here only acts like a bridge, and it just intermediary to facilitate communication between all these trusted components. And using all these outputs from the SQL Server, output from the API call, the one that I mentioned earlier, the client driver issues a query to SQL Server with encrypted parameters. And SQL Server executes the query based on those encrypted parameters and values. And potentially, if it needs enclave, it uses enclave and then returns encrypted results to the client along with key metadata. And the driver decrypts the result using that key metadata and presents them in the plain text to the client side. So this paper was like 15 pages paper, and they explained what happens in enclave in detail and what is the purpose of testation service and what is needed here and how these keys are shared and saved and how the data I'm sorry, the actual data in the SQL Server is used but in a safe way. So I really recommend reading this paper in detail. This is currently used by Microsoft and it was published in 2019, so I'm pretty sure they have like some more news about this too. So they performed performance analysis. They used 4 different settings. One was SQL PT, which is the baseline, had no encryption and connected with a non-always encrypted string. And SQL Server PTAECon had no encryption but connected with an AE string, introducing an additional client-server round trip. And SQL AE used AE for transaction processing, defaulting to randomized encryption with enclave-enabled keys. And variants included different numbers of enclave threads and then a variant with deterministic encryption and non-enclave enabled keys. So results show that AE achieved roughly half the throughput of the plaintext SQL Server baseline. As you can see, this is the baseline that is not using enclave or always encrypted, doesn't use always encrypted technology at all. And if you look at the gray one, the throughput is almost half. And in comparing enclave-based processing with a randomized encryption against non-enclave processing with DT encryption, you can see the right side here. SQL always encrypted, that is using deterministic encryption, performance fell between SQL Server PTAE AECon and SQL AE random here, with 12% slower throughput. And they, the authors of the paper, they pointed out that this performance gap is deemed acceptable given the additional functionality provided by enclaves. So overall, they believe that the results suggests that always encrypted introduces some performance overhead, but especially with additional round trip, but the trade-off for enhanced security feature is considered reasonable. So in summary, this paper provides a good amount of knowledge of the data protection mechanism in Always Encrypted, offering a comprehensive understanding of how client queries are handled from initiation to respond within SQL Server. And they point out Always Encrypted version 2 leverages trusted execution environment, which is enclave, to enable secure computation within isolated enclaves. And this innovation solution has the potential to address critical challenges in the field of encrypted data processing. One weakness or point for future improvement that I noticed in this paper is the observed reduction in throughput with the always encrypted configuration achieving roughly half the throughput of non-always encrypted configuration. So I think for the future work, exploring strategies to enhance performance without compromising security could be very beneficial for a lot of companies and also Microsoft itself. And delve deeper into the specific optimization and trade-offs made in the processed solution, a proposed solution to address the observed throughput challenges could be very helpful as well, I think. And when that happens, of course, I believe every company will want to use always encrypted version 2 because if there's no performance gap, uh, without and also if it offers the most secure high level of security and confidentiality, um, I think it's going to be very intuitive for enterprises to choose this route. So this is the last slide, and then I hope you enjoyed this paper presentation, and I really recommend reading this paper as well. Thank you so much.